Hey, my wonderful students. Hope you have your classwork notebooks ready for this. We're going to be doing some good old-fashioned physics, both conceptual and math. Today we're going to take a complex look at forces and inertia through math and ideas. And I'm going to try to deal with a lot of misconceptions you have about Newton's laws and the applications of it that could leave you confused. So your classwork notebook is open. You're going to be doing a lot of good things for me. Okay, let's begin with Newton's laws. You're about to do a situation with me that's like 5 or 6 steps, but totally worth it. So write down this little situation. A rock with the weight of 10 newtons is resting on a table. A student makes a number of wrong statements about this situation. Here's the first statement. The weight of the rock is a force of 10 newtons by gravity in the downward direction. What is wrong with this statement? Well, the weight is not a force of gravity. Forces are by things, objects. So the correct way of saying this is the weight of the rock is a 10 Newton force by the earth pulling on the rock downward. Gravity ain't an object. Okay. Number 2, the reaction to that weight is a force of 10 newtons exerted on the rock by the table upwards. Well, Jock, it's got to have 10 newtons up, or otherwise it wouldn't move. I agree, but the wording here is disgusting because the opposite force of the weight's 10 newtons down is opposite of that. What? Well, if the earth is pulling the rock 10 newtons down, the opposite force will be the rock pulling the earth up with 10 newtons. So the reaction force to this weight is 10 newtons exerted by the rock on the earth. Whoa, but true. Statement 3. The normal force exerted on the rock by the table is 10 newtons. The opposite of that is the 10 newtons down by gravity. Well, obviously, no, gravity can't make a force, so that's false. Plus, if the normal force is the table on the rock, the opposite force of that must be the rock on the table. You might hear my cat outside. That's adorable. Actually, not outside. It's close by. So, statement number 4. If the 10 Newton rock is lifted off the table by 12 newtons, so you're lifting it up, the reaction to that in 12 newtons is a force of 10 on the hand by the rock in the downward direction. Whoa. No. If the hand is pulling up on the rock 12, the opposite of that is 12 newtons by the rock on the hand down. You pull the rock 12 newtons up, it pulls you down 12. Newton's third law, over and over and over again. Now we're going to look at a mathematical situation, which I've kind of broken down for you. For the following picture, 2 people are pairing Paris Hilton, 45 kilograms, I believe. If the coefficient of friction is 0.4, what's the net force and acceleration on Paris? So here we have Paris, who's evil, because we're born on the exact same day within a couple hours of each other. We have 2 forces left, and we have friction to the right. Here's what I want you to think about this after you're done writing it down. The major idea I'm going to get to you is forces involve relative motion. Positive and negative are just arbitrary. You can choose which way is positive and negative. The major idea is the imbalance or balance, which is revealed through acceleration. And ask, what is the object in contact with? So far, there's a couple things we need to know. We know that weight is mass times gravity, but don't assume gravity is negative. If we define downward as positive, if the imbalance is down, then weight is positive too. We've also said that friction is mu times the normal force, where mu is the coefficient of friction, a number with no units, and normal force is just the force of the surface pushing perpendicular. And finally, we also said that net force also means imbalance. And if balance, net force is 0 because there's no imbalance. And Newton's second law said imbalance equal to mass times acceleration. So those are our major statements that we're going to deal with this. Step 1, draw a free body diagram. I did almost all the work for you. Can you please recopy it down, since you've already done that with the original statement, and add the other forces at work? Pause the video when you're ready. Whoa, pause the video when you're done being ready. Whatever, here's my picture. Notice I added the weight and the normal force. And I'm going to say, let's assume the imbalance is left. We can't be sure of it, though. It could be that Paris Hilton's slowing down because she has so much friction, it's overwhelming these two forces. Let's just assume the imbalance is left. That means the acceleration is left, too. I'll talk about how, if we assumed wrong, what we know. Number 2, please circle the x forces and the y forces, like I've taught you, and figure out if they're balanced or imbalanced. And if they're balanced, figure out which side it is. We said left, and choose it as positive. Unpause when you're ready. Okay, it should look like this. There's an imbalance left in the x's. The y's are balanced. I chose up as positive as randomly, and I have to choose left as positive because the imbalance is always positive according to Newton's second law. Okay, our goals are again to find the friction and the acceleration. Here's what we're going to do. We're going to create net force equations. Here we are in the x. These two forces are positive, friction's negative, and they equal an imbalance. Newton's second law says imbalance equal to ma. Okay? And the mass here is 45. So I can combine these two and have 240 to the left minus friction equals 45a. And friction is mu times the normal force. But what's normal force here? Let's look again in the y. In the y, since they're balanced, the normal force minus weight is balanced. And balance means there's no imbalance, 0. So normal force, move the mg over, equals mg. Normal force is 45 times 9.8, which is 441. It's not negative because the negative was already in front and we moved it over. So now it's just a number. Or in other words, gravity is negative if we haven't factored in the negative in terms of the downward. This negative here refers to being downward, so you don't have to put it in again. So the normal force is 441. So we can solve, put 240 in, we can put 0.4 is the mu, 441 is the normal force, equals 45a. We can solve for the friction, because this is the amount of friction. So what is 0.4 times 441? 176.4 newtons. We found the friction. Nice job. Let's solve for the acceleration now. 240 minus the friction equals 45a. We then can solve for acceleration, get 1.41 meters per second squared. Cool. It's positive, that means to the left. If somehow we ended up with a negative value here, looking back at this picture, if this is positive, this is negative, which means the acceleration would be to the right, which means the imbalance is to the right. So if we end up with a negative acceleration, that means the opposite direction we chose is the imbalance. That's a nice little check, just in case you're unsure of which way the imbalance was. Now, I want you to please look at the homework that I posted online and gave it to you in class and try number 5. We'll go through it and make sure you're okay. Can you please pause, try it out as best you can, and then please press play when you're ready? Welcome back. Elevator lifts a panda up at an acceleration of 2 meters per second squared. Which way is the imbalance? How can you tell? Well, imbalance relates to acceleration. So the imbalance is up because it's accelerating up. Cool. Letter B, which is larger, the up force or the down force? Duh, up force. Because the imbalance is up, you have more up than down. That's the definition of imbalance. Letter C, draw FED of the panda, call the elevator force normal force and the panda's mass m. That should actually read the elevator's mass m. My bad. Here we are. Normal force up, weight down, imbalance positive is up, because that's the way the imbalance is. Create a net force equation for the panda situation. Again, panda elevator, same thing. The normal force minus the weight equals the imbalance. Fn, normal force, minus mg equals ma. If the elevator had 600 newtons of force up, how much mass was the panda elevator? Yeah. Let's plug 600 in here. 600 minus m times gravity equals ma. Notice again, this is positive because the negative of downwards is already in front. And since upward is positive, the acceleration is positive, this is also a positive value. So 600 minus 9.8 m equals 2m. I can move the m's over. I can combine them into 1 and solve for the mass. 50.8 kilograms is the elevator. Cool. This just showed you how to go through all the steps and create an equation every time, solve for it, understand what's going on. You understand the concepts, these two up here. You understand the setup. You can do the math. You're going to be amazing at forces. This is Matthew Jockman signing off.